Hello friends, welcome back to our channel. Today we'll see one more concept in our machine learning, that is radius distance nearest neighbor classification algorithm. So in our previous session we have discussed one classification algorithm, that is k nearest neighbors classification. So this radius distance nearest neighbor algorithm will also be similar to our KNN algorithm. So here also we'll be finding the distances, and just one parameter is different. So there we are choosing the k value. So that means how many neighbors we need to select, and from that we are predicting the output. But here there will be a small difference. So let us start the session. Radius distance nearest neighbor classification algorithm. So first let us see the theoretical part, then we will go with the Python program for this radius distance nearest neighbor. So here the distance measure and the prediction will be done based upon the radius value. So new data point is classified based on radius. So we need to take a radius and we need to consider that radius to predict the new data point. And here also it doesn't create any mathematical model, but it will be using only the trained data, whatever the available data. So no mathematical model will be created. Will be generated from instances. So here you can say instances are nothing but the records, the trained data. Okay, but here we will see working. We will see working so that you can understand everything. So the first step here is similar to our KNN. So here it is also called as RNN. RNN. Okay. So working the first one, all training data will be stored in a memory. All training data will be stored in a memory. Every step is similar. Second, the new data. So here we'll be considering one data set, and from that data set only we have to split it with training data as well as testing data. Okay, so once the training data is stored in the memory, then the new data point will be appears. The new data appears. The new data appears. And then we need to find the distance. Here also similar. So calculate distance between new data point and all instances. So that means all instances of the training data and the new data point. Now we need to consider some radius. So select radius value. And we need to consider all the elements or all the data points which resides in between this particular radius. Okay. Now consider all data points having distance within specified radius. So first we need to calculate the distance, and then we need to find out all the data points whose distance is within this particular radius, and then consider the majority class or category from the neighbors. So here, who are the neighbors? So whatever the data points having the distance which resides within the specific radius, everything we can consider as a neighbors. So from all the neighbors, we need to consider the majority class, right? And finally, we can predict the class for new data point. So here also we'll see the same example which we have seen in KNN. So that is a house prediction, category prediction. So based upon the area, so the house category, that means house class. So whether it is a large area or small area or a medium area. So the same example we'll take. I'll give you an example so that we can go with the implementation part. Okay, I'll implement this one in the Python, right? So by using the scikit-learn or sklearn. So example, let us take an example here. So we can take some area and a class, house class. So for example, it is a 400 square feet. So it is a class small, 500 square feet. Again, it's small, 1000 square feet. It's medium, 1100 square feet. It's medium, 1200 square feet. It's a large. Let us take 1500. Right? And 2000 square feet. It is large. Now what happens? The new data point. What is the new data point? So if I am giving some 800 square feet. 800 square feet. Now we need to find the distance from this 800 to all the areas. So I'll calculate the distance here. So 800 minus 400, it is a 400. 800 minus 500, it is a 300. 800 minus 1000, it is 200. And 800 minus 1100, it is again 300. 800 minus 1500, it is a 700. And 800 minus 2000, it is a 1200. Now we need to consider some radius. Right? So the radius is some 400. So we need to consider all the data points where the distance is within the 400. So you can consider this one, you can consider this one, this one, this one, and this is not considered and this is not considered. So because 700 and 1200, so which are beyond the radius, so we should not consider that one. So we need to consider only the data points which are within that particular radius. So 400, 300, 200, 300. So we need to consider only these data points. So among that, we need to consider the classes called medium. How many mediums are there? How many small are there? So in this case, we got 2 medium and 2 small. Okay. Now what will be the result? So we are saying that we need to consider the majority of this class, but here we got equal. So this is called as a tiebreaker. It's called as a type. Okay, there is a type because equal distribution is there. So here we need to consider the tie-breaking rules. So in our previous session we have seen this one, tie-breaking rules. So that means we can consider the closest one, okay, which is very closest to this one, 800, which is a very close to this one. I think 800 we can consider 1000. 1000 is more closer than 500. So directly we can consider it as a medium. Or we can calculate the distance. We can calculate the distance, and based upon the distance also we can consider the closest neighbor. Or directly we can go with the random generation. Randomly we can go with. So all these are called as a tie-breaking rules. Tie-breaking rules. So now let us take 300. Okay, let us take now 300. So if it is 300, we should not consider this one also. We have to consider only these things, right? 300, 200, 300. Now, how many mediums are there? 300. So it is, yes, 2. And how many small? 1. And how many large? So there are no large, 0. So what we need to consider, we can consider the majority, so medium. So the result for this one is medium. The result of this 800 square feet is medium. So this will happen based upon the radius. We need to consider the radius, and we need to consider all the data points where distance is within this particular radius, and we need to perform. So this is the approach we are using in radius distance nearest neighbor classification algorithm, which is RNN. Now I'll stop here, and let us move on to the system, and I'll show you the implementation of this particular RNN, okay, in our system. So let's move on. Hello friends, just now we have seen the complete theoretical part of one more classification algorithm based upon the distance measure, that is the radius distance nearest neighbor, which we can also call as RNN. Now we'll see the implementation, so in Python. So this is also very similar and very close to the implementation algorithm which we have seen in our previous session, that is k nearest neighbor classification. So here also I am using the same data set which we have seen in our previous session. So let us start one by one, line by line. So first one, for every ML program, we need to testing the data and the training the data. So we need some data set, and for that data set, we need to use a data frame to represent that data set. That means in terms of rows and columns. And for that, we are using the PANDAS library. So the first line gives a PANDAS library. We are giving some alias name, that means our alternate name, as a PD, so that wherever we just want to use the name PANDAS, we can replace it with PD. And the second line, see, a scikit-learn is a library. In that library, we are having a model selection, which is a module. In that module, we are having a function called train test split. So this function, the name itself indicates it will split the complete data which we are giving in the data set into training data and testing data. So for splitting up of data set, we are using this train underscore test underscore split function. And this function is available in a module called model selection, which is in the sklearn library, sklearn or scikit-learn. And the third one, again, we are not writing the program from the scratch. We are directly using a class called radius neighbors classifier. So it is an algorithm, right? So already implemented, just we are using that particular class, and that class is available in the neighbors module of scikit-learn. So scikit-learn is having a one more module similar to our model selection, that is a neighbors. So sklearn.neighbors, we are importing only one class, that is a radius neighbors classifier, because this is the program where we are implementing this radius nearest neighbors. So the class name, again, we need, as I am saying, it is a class name. There is a naming function, naming conventions. So R is a capital, N is a capital, and C is a capital here. Now, the first step, we need to load the data set. So what I said is, whatever the data set we have used in our previous algorithm, that is a k nearest neighboring classification, the same data set I am using here. So the location is similar. So D machine learning k nearest neighbor classification house prediction dot xlsx. So this is a Excel file, and I'm creating the data frame. So data frame is a two-dimensional data in order to represent the data in a two-dimensional. If we want to represent the data in a one-dimensional, we will call it as a series. So but here we are just giving the two-dimensional data, so we are using the data frame. So just I'm printing the data frame. So whenever you execute this one, first the data set will be converted into a data frame, and that data frame will be displayed in your screen. Now we need to take a two components, x and y, where x consists of the input and y consists of the output. So here, as it is a classification algorithm, so there are three classes. So here we are taking an example of house prediction. So based upon the area we have given, it have to classify the status of the house, like large carpet area or small carpet area or a moderate or medium carpet area. So based upon the area, it have to categorized in one among the three: large, small, and medium. So for that, I'm taking df area. So here you can see this is our data set. uh, so there are three columns: house id, area, and house underscore class. So here area is a input and house underscore class is the output. So the input which we want to give is a area, and the house class, it should category based upon the given area. So x component we are taking the area, and y component we are taking the house class, which is a data frame. Right. The next step, we need to split the data set. That means whatever the data we are giving here itself, we are dividing the data into two halves, not halves, two parts. One is a training data, another one is a testing data. So here we need to give the syntax: x underscore train, x underscore test, y underscore train, and y underscore test. So here we are representing the input and output as x comma y. So training, there will be x component; testing, there will be a x component, as well as training there will be a y component, and testing there will be a y component. So we have to use a function called train underscore test underscore split, and here it takes a four parameters. One is a x, another one is a y, and another one is a test size. Here we have given test size as 0.2. That implies it will be 20% of 20% is the testing data, and remaining 80% is the training data. So it will automatically split. It will take randomly some 80% of the data from the data set as a training data, and the rest of the data in the data set will be considered as a testing data. So here we can replace this 0.2 as 0.5. If you represent it as a 0.5, that will be 50%. The data here in the data set, we are having around 40 records. Among these 40 records, now it will be 32 records will be training data, and 8 records will be the testing data. And random state, in our previous session we have explained this one. So every time you run the program, the same set of data will be considered as a training data and the testing data. It's a non-zero value, and 42 is uh, in general value, so you can replace that value, no problem. So you can give any other non-zero value other than a 42. And now we need to use the class called radius neighbors classifier. So we are creating an object called RNN. RNN is an object created for this particular class. So here we have to consider the radius. Whereas in our previous session, we have considered the k value. That means how many data sets we need to consider close to the new data set. But here, instead of considering the k value, the number of neighbors we need to select, here we need to use a radius. So radius means it will collect all the data within that particular radius. So I have given here radius is equal to 400. So you can change it to any other number. Next, training. First we need to train the model. So for train the model, the function is a fit. So object rnn.fit. rnn.fit. So this function is in the class radius neighbors classifier. So we have called this particular function with the object which was created from this particular function, this class. So rnn.fit, xtrain, and ytrain. Now we need to test the data. So testing the data, we know y is the output and x is the input. So y underscore predict is equal to rnn.predict function x underscore test. So this method, fit method is for training the model, and predict method is for testing the data. Now see, we are taking, so after this prediction, the training is successful and the testing is successful. Now we need to give a new area, that means new input, so that it have to classify. Right? So here we have given some area, and new house is equal to data frame. We are giving the input data frame. So whatever the area here we are giving, that will be passed to here. And now predict. So we are using the predict function because predict is to predict the output. So this is for testing. So here we are using the same function. So prediction is equal to new house. So the same thing we are displaying in the output. Now let us consider. So let us execute this one. So execute. First, what is that? First data set will be created. A data set will be created. I mean into data frame, and it will be displayed here. It was asking for the new house. So I'll give here 1250. 1250. Okay. See, obviously we are getting the predicted house class as medium. So how we are getting the medium? Let us manually check. So what is the thing we are given? 1250. So here first it will find the distance among the new point with all other data points. So here let us consider the distance absolute 500 minus 1250. The same thing will be applied for each and every instance. Yes, yes. Now you can observe what is the radius we have given 400. So we need to consider all the instances which are below 400, which are below 400. So let us take this one. So I will clear this one and I'll use this distance. And now let us sort this one, or you can select whatever the thing. See this one. Oh, sorry. So let us sort this one so that we can get smallest to largest. Yes. So we can consider all these. See, we can consider all these. That means till 400 because radius 400. So 450 we should not consider. We need to consider only these many. Okay, we have to consider only these are things. That means less than 400. So among that, you just count the categories. How many categories? Majority votes. So medium. How many mediums? So 10 mediums are there. 10. And how many large? 2 large. And how many small? 1, 2, 3. 3 small. So we have considered how many predictions, how many neighbors we are considering. The neighbors, 15 neighbors. So among 15, 10 are medium, 2 are large, and small are 3. Now we need to consider the medium. I mean, we need to consider the majority. What's the majority? 10. So that's why we got here medium. So this is a common. So we need to calculate the distance from the new point to all other instances which are in the training data set. So among that, we need to classify, or we need to count the classes, different classes, how many instances fall under the class, and we need to consider the majority. So here we got 10. So 10, that is a medium. So we got the result as a medium. So this is how the radius neighbor classifier will be used. Okay. So instead of selecting the nearest, how the number of neighbors, we are giving a radius and we are considering all the instances, all the neighbors fall under that particular radius. And we are predicting this one. So hope you understood this simple radius neighbor classifier algorithm. Right. So I'll stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.